Okay, so today I will be presenting on technology standards for hydrogen fuel combustion facilities. So in 2018, California Senate Bill 100 set the goals for the state's transition to zero carbon by 2045. This was in an effort to mitigate the growing threats of climate change. And in California, natural gas plants meet much of the electric generation needs for California and are often located in California's urban centers. Rather than shutting down these plants, many utility companies in California are planning to repurpose plants to combust hydrogen gas rather than natural gas to meet the net zero targets. SoCalGas, for example, plans to use hydrogen to decarbonize in its plan for Angeles Link, which is a plan to inject hydrogen into existing natural gas infrastructure, like the example shown here. Last year, they successfully blended 20% hydrogen in a test natural gas system, complete with natural gas residential appliances. And similar pilot studies are taking place at utilities across the country. So just to quickly introduce the governing bodies, the California Constitution authorizes the California Public Utilities Commission, the CPUC, to develop rules and regulations for utility companies and infrastructure in California. And the CEC helps ensure facilities are located, constructed, and operated in a way that protects the environment and public health and safety. The California Air Resources Board defines the state's strict emission standards to protect air quality. These bodies often work together. So just as an example of their influence on planning and policy, the California Energy Commission is spending millions to study how natural gas blends or even 100% hydrogen will be handled by existing natural gas infrastructure like pipes. But beyond addressing these engineering and safety issues with pipes, the impacts of hydrogen combustion on public health and climate need to be adequately addressed. While no carbon is emitted, burning hydrogen can lead to the formation of nitrogen oxides, or NOx, in quantities even greater than that of natural gas or other fossil fuels. And we're talking up to 6 times more NOx emissions than its natural gas predecessor. And NOx is a globally regulated air pollutant already that is harmful on its own, but it's also a precursor to other pollutants such as fine particulate matter and ozone. And NOx has direct and indirect effects on human health. It can cause chronically reduced lung function among many of the other health impacts shown here. And indirectly, it can affect humans by damaging the ecosystems that we rely on. And so NOx as a byproduct of hydrogen combustion is rarely discussed when we're talking about it as a future climate-friendly fuel. Natural gas plants that would be converted to hydrogen are often located in communities facing socioeconomic disadvantage. And the conversion in these areas to hydrogen risks adding to the environmental and health burdens of these communities, and they cannot be left out of the conversation. So alongside further study by the CEC, my recommendation is that the California Air Resources Board needs to develop hydrogen-specific best available control technology. And so that's called BACT. And so they need to develop guidelines for the best available control technology. In California, BACT guidelines already exist and are a requirement to use technology to achieve the lowest possible emission rates for specific pollutants. And NOx minimizing technology has been specified for natural gas, such as the technology shown here. These mitigation technologies have not yet been demonstrated at the NOx levels and temperatures for hydrogen and may not have the intended effect. So the Air Resources Board needs to identify all available control technologies, identify the most effective and feasible for hydrogen, and set standards for the acceptable technologies for NOx mitigation for hydrogen. So just in general, as we approach decarbonization, we need to ensure that zero carbon does not mean other problems for air quality, health, and the environment. We need to have proactive evidence-based policy that will keep our energy systems reliable and our communities healthy. And in this case, that means hydrogen-specific technology standards. Thank you.